Hey, what's up, everybody? Once again, it's Jeremy from the Renegade Coder, and today I'm looking to cover my favorite Python feature, which is the list comprehension. I've talked about them a little bit in the past in videos, but today I'm actually looking to give you a definitive guide of what list comprehension is supposed to look like, and then hopefully we'll have a lot of fun with that. But before we do that, I wanted to talk a little bit about something I had noticed in some of my previous videos. Specifically, I actually tried watching one of my videos on my phone the other night, and I noticed that while the text might look big on your computer, it looks really, really small on a phone, and I was actually having some trouble reading my own code. So I have bumped the font up on this editor to 44. It's a pretty random number, but it was 36. It's now 44. So hopefully that improves the experience if you're working on your phone. Otherwise, let's go ahead and get started. If you've never heard of a list comprehension before, the idea is that we want to generate a list basically in one line. So typically, if you wanted to create a list, you might do something like this, where we actually maybe wanted to make a list from 1 to 10. So we actually have to hand populate this list or hard code it so it looks like this. Or if you were clever, you might realize, oh, there's a pattern here in this list. I could generate this exact same list using a loop. So we'll go ahead and do that with a separate list called y, and we'll say for each item in range of 1 to 11. So that ending index or that ending value is actually exclusive. So then we'll do y.append, and we'll pass that item into the list. So now y should look exactly like x. But there's actually a third way to generate this list that's going to be quite a bit more elegant, and it's using what's called a list comprehension. So if we want to generate this exact same list, we actually open with a bracket, and so I'll call this list z, and then the first item that goes into the list comprehension is what you actually want to store. So for right now, I'm just going to use a placeholder variable. We'll call it item. And then we'll say for each item in range 1 to 11, done. So now what you're looking at is the exact same loop that we had from above, but it's on what I'll call the right half of the expression. And then on the left half is the value that we actually want to store. So for each item in range, store item in this list. And it's basically this exact syntax, but compressed to this abbreviated syntax. And this syntax is called a list comprehension. List comprehensions are great because they're extremely powerful. What we just did was generate a list from 1 to 11, but we can actually do things more interesting than that. So we'll go ahead and write that same list comprehension, item for item in range 1 to 10 or 1 to 11, and then we can actually modify the result. So you could imagine for each item in 1 to 11, we want to divide each of those items by 2 and store the result in the list. So now what you see is instead of 1 to 11, you see 0.5 to 5. We can actually do plenty of things just as interesting as that. We can go ahead and do item plus item, which will give us the double of each of the terms. We can do maybe the exact same expression, but items times 2, same list. Your options are pretty much endless. You can modify item as many times as you want, and you're going to get different results based on how you change item. So even as silly as item times 0 is going to give you a list of zeros. Anything really, your options are wide open. Another thing that I think is pretty interesting about list comprehensions is that we're not restricted to using the range function. We could actually do another list comprehension, but just use a string, So now strings are iterable. We can iterate over each character in this string. In this case, we're calling each character an item, and we're going to store that item in the list. So as you can imagine, the resulting list here should be each of the characters. And then again, we can do something funny where we can add, an exclamation point to each of the characters and get each of these characters with an exclamation point next to them. Again, it doesn't really matter what you're iterating over. So as kind of a funny idea, you could then nest list comprehensions where maybe we would have another one here and we would say x for x in range 1 to 11 again. And then what do you imagine would happen here? Well, this inner list is going to be generated with the numbers 1 through 10. and then the outer list is going to iterate each of those numbers and store the results. So we're not actually going to get anything all that interesting. We're just going to basically generate that list and then generate that exact same list again. But we can here modify item again to maybe do over 2 or something like that. So now at this point, we have the basic foundation of a list comprehension put together. Now, all we really want to do is start looking at some advanced features. So as you can imagine, if we took our same list comprehension, so we say item for item in range 1 to 11, we can now extend this to do some filtering. And what I mean by that is we can add if statements to this that will actually filter out values. So let's say we wanted 1 to 10, but we only wanted the odd numbers. So we would say if item, %2 equals 0. So this case, we will only get the even results. And then we can do the same thing to get the odds. And you can imagine that this if statement can be modified in any way that we want, as long as we have a valid condition here. So let's say we want anything that's divisible by 3. Okay, then we only get 3, 6, and 9. We want values only divisible by 4, 4, and 8. You get the idea that we could pass pretty much any condition here, and as long as it passes, we're good to go. So as you could imagine, maybe we're searching for an item in this list. We could say if item equals 7, then store it in the list, and we'll only get that item 7. Or we could filter out 7 by saying as long as the item doesn't equal 7, we'll get everything else. So you can imagine here that we can use this if statement at the end of our list comprehension to do filtering. Now, probably to no surprise, we can actually start mixing these features. So for example, previously we talked about how we could modify the return value. So in this case, we could do division by 2 and then say for item in range, and we're actually going to extend the range here. Let's do 101. So now we're going to have 100 values in our list. And then we're going to filter only the even ones out. So we'll say as long as item %2 equals 0, the resulting list here should be all the even items from a list of 1 to 100, but divided by 2. So then what you can see here is we get 1, 2, 3 all the way to 50. Now we could have easily just generated a list of 1 to 50 here, but I just kind of wanted to show you that we can filter and we can modify. So we can do maybe the same thing, but only take odd numbers and then maybe multiply them by 3. So now you get all odd numbers from 1 to 100, and then you've multiplied all those terms by 3. Now, to perhaps no one's surprise, we can actually carry this list comprehension idea a step further by introducing nested loops. So if I say, and I'm going to get rid of the item idea for now, we'll just say x and y. I want to add x and y together. And then what you can imagine is for each x in range 1 to 11, and then for each y in range 1 to 5, we will sum the result. So what this is going to act like is a nested loop. So for each x and for each y, we will generate the sums. So what you can see here is we'll add 1 and 1, 1 and 2, and continue on until we've added all pairs of combinations. And then what you can probably imagine here is that we could use this here to perform multiplication. But unfortunately, that range function isn't always clear. So let me actually replace this with what you would expect to see. So we'll only go up to 5 here, and then we'll go up to 3 on this side. And you can imagine that we're going to pairwise multiply all possible combinations of these two lists. So 1 with 1, 1 with 2, 1 with 3. Then 2 with 1, 2 with 2, 2 with 3. Then 3 with 1, and so on. Oops, I made a mistake here. And then as a result, you can see sort of that relationship here. 1 with 1, 1 with 2, 1 with 3, 2 with 1, which is here, 2 with 2, which is 4, 2 with 3, which is 6, and you get the idea. I think my favorite use case for list comprehension beyond just straight up generating new lists is actually duplicating lists. So if I had some list that was 1, 2, 3, and I wanted to duplicate this list, then I can write a simple item for item in X comprehension, and that will give me a copy of X in Y. But what happens if we have nested lists? Well, what we can actually do is write a nested comprehension. So what you can imagine is, let's say we redefine x as being 1, 2, 3, and then 4, 5, and 6. Oops, just made a small error here. And then we're going to store the results in a new list, but we're going to use a fancy list comprehension. So let's rewrite y so that what it does is it says sublist for sublist in x. And what that means is I want to iterate over each sublist in this list. So at the first iteration, we're going to grab 1, 2, 3. At the second iteration, we're going to grab 4, 5, 6. But if we run this as is, y is going to look correct, but it's not correct, because now if I do something like this and I say, is y at 0 also x at 0? And you're going to return true. And that's a problem, because that means that if I modify y at 0 and set it to, let's say, 7, let's go ahead and modify 0 at 0, set that to 7, then y looks like this, but so does x. So we've now corrupted x. So let's go ahead and fix that. Set that back to, what was that, 1? And now x and y are fixed. And let's go back to our list comprehension and fix it up. So right now we are creating sublists, but they're just copying the references. So we want to actually copy the sublist. And so what we'll do is we'll actually create this here. And we'll say item for item in sublist. As long as this is written correctly, we're going to iterate over each sublist on the right half. And then on the left half, we're going to iterate over each item in the sublist. And as a result, we should get the same list. However, now y at 0 should be completely different than x at 0. And now we're fixed. So if I decide now I'm going to change this again so that it stores 7, y should store 7, but x does not. So we've properly created a copy. And that's one of the reasons I really love these list comprehensions. It makes it really quick and easy to create a copy outside of just calling the copy command. And as you can imagine, you could probably handle special cases, which is nice. All right, well, as usual, that's all I've got for you today. Hey, thanks for sticking around and letting me teach you my favorite concept in Python. As always, make sure you stick around and hit the like button, subscribe, maybe watch another video. Whatever you can do to help me out, I'd appreciate it. Otherwise, head on over to Patreon. I'll have the link in the description. And again, as usual, special thanks to Encole36 for providing the artwork for this video. Again, I'll link them in the description as well. Other than that, thanks.